She is a graduate in physics and has gained her master's in applied science from Bardiyar University. She holds an MPhil in computer science from PSG College of Technology, Bardiyar University, and a PhD from Anna University. She specializes in the area of blockchain, Internet of Things, and wireless protocols. Her research has contributed to the computer network domain. At Coimbatore Institute of Technology, she has been engaged in a wide range of activities involving teaching, research, and administration. And this session is over to you, madam. Madam, you can take this session.
Thank you, sir. Am I audible?
Yes, madam, it's audible.
Okay, let's start. Okay, let's start the session now. Yesterday, you would have actually learned what a blockchain is and what a cryptocurrency is. Okay. Today, we'll see how Bitcoin, a cryptocurrency system, is implemented over blockchain. So we just combine the technologies, blockchain and cryptocurrency, and we'll see how it is actually working. So this is today's agenda. So first, when you hear the term Bitcoin, we just think it's actually a currency, maybe a virtual currency or whatever it is. This is the one which comes to our mind first. It's actually currency. Yes, it's correct. But it's purely virtual. You can't see anywhere. Okay. Actually, at the most, you can see that as a transaction in a blockchain. It's a transaction in a blockchain which could transfer a value from a source to a recipient, sender to a recipient. That is all we can see. Nothing else we can see. That's why it's termed as virtual. Okay. So this is the first cryptocurrency system successfully deployed over blockchain-based network. Okay. But actually what it does is, it just records the various transactions happening all around. That is all. Okay. So this is as an user perspective. Okay. Now we'll see what exactly a Bitcoin is from the technology perspective. So it is not just the Bitcoin, it's not just a currency. It is actually a combination of or a collection of technologies. So there are four important aspects. The first one is, you can call that to be a decentralized peer-to-peer network who can speak Bitcoin protocol. So from this line, we could understand that this is a protocol. It is not just a currency alone, it is a protocol. Okay. So this is actually a decentralized peer-to-peer network which can speak Bitcoin protocol. That's the first step. Second step is, it is actually a public transaction ledger. This you would have heard from the blockchain thing. So it is actually a ledger. You can call it this way also. It's a transaction ledger. And the third aspect is, it is actually a set of rules which could validate a transaction and when exactly the currency need to be issued. So this will also provide a set of rules. When to give currency, when to raise the currency, when exactly the transaction has to be added, how is it to be validated, all are defined as part of this Bitcoin. And the last one is, it is decentralized, right? So before adding a transaction to a Bitcoin network, right? So all should say, okay, this is correct. Okay. So some consensus agreement need to come, right? So this Bitcoin protocol has its own consensus algorithm. Okay. So from the developer's perspective, Bitcoin is actually comprised of these four. It is actually you can call that to be a protocol, Bitcoin protocol. It is actually a ledger, right? He is the one who's going to give you the rules of validation of all transactions, and you have a consensus mechanism to get concurrence from all the participants. So all these four put together, it's called as a Bitcoin. Okay. So how to know why cryptocurrency is required, right? It is required to avoid the third party, any government or any finance or any bank in between the sender and the recipient. So that is why we are moving into this cryptocurrency. Okay. Okay. So now first, let me talk about from the perspective of a Bitcoin user, what he needs to do, how to communicate with the Bitcoin. Okay, later on I'll tell you from the developer's perspective, how it is actually implemented. Okay. So the first thing is to get connected with this Bitcoin technology, what you need to have is a client application. So as we use a browser to get connected to this internet, right? Likewise, to get connected to this Bitcoin network, you need to have a client application that is called as a Bitcoin wallet. Okay. So that Bitcoin wallet knows to speak Bitcoin protocol, right? You know how to converse with the rest of the nodes. That's Bitcoin wallet. Wallet is actually basically it is an user interface, right? Using which you can communicate with the Bitcoin network. But actually, it allows you to manage your money, your virtual currency, and it can manage certain keys. We'll see what are the keys available. And we could actually send money to others, or you'd be able to receive money from others. All these things can be done with the help of this wallet. Okay. So from the programmer's perspective, the wallet actually it is just a data structure which is used to store the manage the user keys. Okay. So now we'll see what are the user keys. Before that, let me tell you what are the currently available wallets. Okay, so these are the best Bitcoin wallets of 2020. You would have noticed two terms. One is hot wallet, another one is cold. So in case if it is a hot wallet, right, it is actually all your keys, everything will be managed by some third-party server. For that, you need to have a connectivity. Internet connectivity is needed. So you're live. Okay. So to make a transaction or to get hold of a data, right, you are live, right? Whereas in case of cold wallet, right, you would be given a specific device, right, where you could store all your keys, right? And whenever you want, you can open it. And if you don't want, you can close it and keep it aside. That is actually, it is not directly connecting it to this internet for the managing purpose. Of course, for transaction, you have to go online, no other node. But the thing is, but all your data will be locally stored. It is safe actually, but the difference is you may require to have a hardware component associated with it. You need to buy it. Okay, so you need to pay for that. It comes around $100 approximately. Whereas if it is hot wallet, right, you are just going to use an application, right, using which you can actually manage all your data. So these are the best Bitcoin wallets of 2020. So this is how a typical mobile wallet will appear to be. So this is a very old shot of course, right? So hope you can see like you have to your accounts, how much balance you have, how much transactions you have done, right? You have options to sell and buy Bitcoins. A lot of other options are there actually. This is how a typical mobile wallet will appear to be. It is just an application which allows you to communicate with the Bitcoin. Okay. Okay. Now assume that you have chosen a wallet of your choice, right? Based on all requirements. So certain wallets will just can understand only Bitcoin. So the other wallets may have a lot of currency supported. A lot of the features are there, right? Based on which you can choose one particular wallet. Okay. Now that you have a wallet, now the next step is to get a Bitcoin, right? how to get a Bitcoin as a new user. One is you could find a friend who has Bitcoin and buy from him directly. You can give the hard cash and you can ask him to transfer the money to your wallet. Right? There is actually a group available. This is a link, right? So there is a meetup. This link will have like subscribers who are using Bitcoins, right? So you can go in there, you can find out a friend, and you can trade some amount of Bitcoin from them. That is one way. Another way is in your area you can find a Bitcoin seller, right? You can go in person, give the hard cash, and you can ask him to transfer the Bitcoin to your wallet. That is also possible. And the third one is you can have a there are ATMs available. Okay, so you can go to this ATM and which will actually accept your money and it will transfer the Bitcoin to your wallet. That is the third option. Or the fourth option is you could offer some service to somebody, right, and ask them to pay back in terms of Bitcoin. For example, I may take a tuition to somebody online and I can ask him to pay in my wallet. That is another option. So these are the various ways in which you can acquire your first Bitcoin. Okay. Okay. Now you have a wallet. You now have a Bitcoin. You own some Bitcoin. Now, obviously, the next step is to use it. Right? What you can do is, suppose if you go to a shop and you get something from there, right? So the point of sale which we have currently could have been modified for Bitcoins. Okay. So he'll produce a receipt. So you would have bought some list. So he'll charge you and he'll get a list as usual, right? So where you will find a special QR code. Okay. For the amount of money, his address, right? Everything. Now you need to use your wallet to scan that QR code and you can pay. This is how the payment happens. The usual procedure, right? He'll charge you, right? He'll get you a receipt, right? So in that receipt, there will be a QR code generated, right? So you just need to scan it in order to pay for it. So that is how you actually pay. Okay. So this is how a typical transaction appears to be. What we have done is a transaction, right? So I bought something from him and I'm paying him back. This is a transaction, right? He's paying, I'm paying him actually, right? This is a transaction. I send so much amount of Bitcoin to him. Okay. So this is a transaction. So this is how a typical transaction is. So this is actually, I've used some tool to get hold of this transaction, right? It is not just the raw bytes I'm showing you, right? Each transaction will have an ID. The first row, the first, is my mouse pointer clear? Is visible? Are you all there? Hello?
It's audible.
Yes, ma'am.
Okay. So the first is my the transaction ID, right? So this is the input. This is the input amount. I'm paying him. Okay. So I should pay him some amount, and I should have something as a change, So these two are the things. So this is the payment I made him, and this is a reminder which need to go back to my wallet. I hope you see this ID and this ID are the same actually, because the change needs to come back to your account. So this is how a typical transaction is. We'll see this confirmations, everything later. We'll just see the summary. The size of the transaction is just 258 bytes, right? So when is the transaction received? That's received time. This is actually included in a block. I'll tell you how it is to be included in a block later. It's already done actually. So the block in which this transaction is present, its number is given here, right? And the total amount, the input amount is 0.1 BTC, okay? And I need to pay him 0.05 actually, okay? And this is the unspent amount. So all these things are there, okay? So this is the actual amount I've paid. So this one extra element is there, that's a fees, right? I need to, because I'm doing a transaction, right? I'm supposed to pay an incentive, right? For my transaction to get included in a block, right? So I made a transaction. So that transaction need to be included in a block. So For including my transaction into a block, I need to pay a fee. That amount is called as the transaction fee. Okay. Right. So that transaction fee plus the actual amount, everything is added up and shown here. Okay. So now here, this is some, it's written in blue, right? This is actually a transaction which has given me this much amount of bitcoins. So now normally when you pay something for a service, right? After getting, or I'm paying something, right? I don't need to prove that this is my own money in ordinary case, right? If I'm spending out of my pocket, right? I don't need to prove that this is my money because it's coming out of my pocket. It is my money, obviously. Everybody assumes that, right? But here you need to prove that this, you are owing this much amount of BTC. Somebody would have given you that money, no? So that is linked with this transaction. Okay, so we'll see that. No, so this is not just an ID. It's not your address actually, right? So this is actually, this is pointing to a transaction which has given me this much amount of Bitcoin. Somebody would have given me an amount, right? So I have to prove that I'm an authorized person to spend that money. Okay, right. So that actually, this amount, no, this is actually called as unspent transaction amount. Okay, we'll call that as unspent transaction amount, output, transaction output. So this is how a typical transaction would have happened after getting a coffee, as per this example. Okay, now that, hope you understand what the transaction is, right? So this is how a transaction appears to be. So these are the input parameters to the transaction, and these are the three output fields generated. I'll try to explain. So this transaction hash, this is what I told you, the pointer to the transaction containing the unspent transaction amount to be spent. So this much amount of money I'm owning. Okay, somebody had given me that, right? So that transaction's hash. Which transaction has given me this amount? That transaction, right? Yeah. So that transaction normally will have a set of outputs. I'll tell you why you require to have a set of outputs. In those outputs, which is the index? Is it the first output, or is it the second output, or the third? That index number. So this is the transaction hash, which has given me this amount. Okay, so within that transaction, what is the output index? Is it the first transaction output, or is it the second transaction output, or the third? Okay, and then I need to prove that I have rights to spend this, right? So that proving happens through these two: unlocking script size. This is just the size actually. This, you can imagine it to be a script like JavaScript or something, some very simple script, maybe 1 or 2 lines of code. Okay, so that there is an unlocking script, right? So the unlocking script size is noted here. That's it, right? So this will prove that you are the owner of that unspent transaction amount. O stands for actually output. I just call that as an amount. Okay. And you have a sequence number. So this sequence number is a field. Actually, if it is set equal to 0, your transaction will not be included in a block as soon as it is generated, right? So it will wait for some time. Till that time, you can have any modifications done to this. After then, it will be added up to that block. Okay. So these are the inputs to a transaction. So a transaction normally gives an output, right? So the output is how much amount you are transferring to an address, right? So the we call actually paisa, right? Likewise, in Bitcoin, we call that as satoshis. Satoshis. It's Bitcoin is not the minimal amount. Okay, satoshis is a minimal amount. It's actually 10 power minus 8 Bitcoin. Okay, so how much I should express the amount in terms of how much of satoshis. Okay, how much of amount I'm sending. Okay, then I have to give his address to whom I'm transferring, right? So for that, I should write a script. Again, I should write a script saying that I'm sending this amount to this person. He has to show me back, not to me. He has to show the Bitcoin network that he is so and so. That script, no, that script size and the script is given here, right? That's locking script. So the whole thing is locked actually, right? He has to specify the amount and to whom it is to be transferred, right? And the to whom it is transferred is expressed in terms of this locking script. So the locking script normally gives the public key of the receiver, right? At later, when he need to actually use this amount, he has to show the private key. He has to use a private key to unlock it and then use it. Okay, so that is the script actually. Don't think the script is very big. It's just like 2-3 opcodes are there in this as a part of the script. Okay. Hope you got this. So this is how I've just explained what a transaction is. You have set of input here in this diagram. You just have only one input and there are two outputs, right? So there are two outputs. One goes to a person, one comes back as a change, right? So that is what the index means actually. The index is output index is you have a transaction. There is only one transaction, but there are two output elements. This is index 0 and this is index 1. Okay. Okay. So now, just now I told you about this transaction has to prove that I am the owner of that unspent amount, right? So that forms naturally a transaction chain. Okay. Each new transaction has to refer the previous transaction. Okay. So in this case, the example which I had shown earlier is that Alice is paying for a coffee actually. Okay. So, but Alice has got the Bitcoin from a friend Joe, right? So while she's paying the amount to this Bob's Cave, right? She has to prove that she has got the amount from Alice, from Joe. Okay. So Joe would have given an amount and he would have actually locked the script, right? So to open it, you have to provide your public key in order to open it and prove that this is mine actually. Okay. So this is how a transaction chain is formed. Okay. So this is all actually, I've explained everything actually. Okay. So now this is actually the various ways in which you can form a transaction. So this is what we had seen just now, right? So Alice got some money, she's spending to Bob, and the change goes back. So I just have only one transaction output that is being spent. Suppose I have to pay a huge amount of money to some person, right? But I don't have one unspent transaction amount matching that BTC, right? So I may have lots of unspent transactions. I can combine all those unspent transactions in order to pay an amount to another person. Aggregating. Sometimes, so in this case, it's just two, right? So you can even have more than one. I have a huge amount of money which need to be distributed among a set of users. Means I can have distributing function can be done. Okay. So what we have seen so far is just we have seen what is a wallet and how to become a user of Bitcoin. Okay. Right. So now, having formed a transaction, right? You need to pay a transaction fee. One reason I told you just now, it is you have to pay an incentive, right, to include your transaction in a block. Right. This is one reason. Another reason is the same transaction fee is used as an disincentive against abuse of the system by imposing a small cost on every transaction. Somebody intentionally they are inducing some blocks. You have to put a restriction to that on that. Right? To put a restriction, you can make them pay. So if they are going to pay for what mischief they're going to do, they normally actually will restrict themselves. So in that idea, they are charging it. You can consider this transaction fee as an disincentive. Okay. And remember, this transaction fee is not calculated based on how much amount of money, how much amount of BTC you are transferring, right? It is not so, right? It is just actually the size of your transaction, how big it is. Suppose if I have one input and set of outputs, right? So my transaction size will be huge. So in the example which we had seen earlier, it consumes only some around 200 and plus bytes actually, right? But I have more than one input, or if I have more than two outputs, then my transaction size will grow. So based on the transaction size, I need to pay an amount for as a fee. Okay. So actually, I'll introduce what a miner is later, right? So the miners need to pick up all your transactions and he has to form a block and add it to the blockchain. That is his goal actually, right? He'll compile, he'll take a set of transactions, put it in one block, right? And the block need to be appended to this blockchain. That is his main work, okay? So when he chooses out the transactions, right? He can prioritize based on some criteria. So one important criteria is the incentive, how much you are willing to pay. Normally he will choose the transaction which is paying more incentives. Okay, so that is one thing. Another thing is, so you may not know, like, because if you are doing by hand, right, you may not know how much transaction fee you need to pay, right? So to fix a transaction fee, there are sites available. I'll show you a way. So this is a site which will show you, right? Suppose if I am paying 0 incentives per byte, satoshis, everything is in terms of satoshis, right? I need to pay 0. Suppose I'm not willing to pay any amount, right? So 0, right, per byte, not for the whole block, whole transaction, it's per byte, right? So if I'm not willing to pay anything, I'll have to check out how long will it to take for me, for my block to get, for my transaction to be added to the block. It takes actually 42 minutes, I suppose. So unit differs from site to site actually, right? To infinity, right? Minimum. You have to at least wait this much amount of time before your transaction gets added up to the block. So actually this is 42 is in terms of blocks. You have to wait at least 42 blocks before your transaction gets added up. Or else I could say it takes the 300 minutes for your block to get, for your transaction to get added into your block to infinity, right? Likewise, they would have given a range, right? So based on how much you are willing to pay, you can predict, right, how much time will it take for your block, for your transaction to get into a block. So based on which you can choose the transaction time. Right? So you can, based on which you can fix the transaction amount. Okay. So now I think hopefully you would have got an idea what a transaction is. Right. So now we need to see about the network. So we say it is a peer-to-peer network which sits over internet and it can speak Bitcoin protocol, right? So now we'll see what are the components of a Bitcoin network. Okay, so it is basically, it is going to sit over the internet, right? But you're going to structure it as a peer-to-peer network. So you will have a direct connection from your node to the another node of your Bitcoin. See, the possible nodes of Bitcoin network are, right? Your wallet itself can be considered as a node, okay? And you may have certain nodes designated for transferring your transaction or a block, whatever it is, to the other side. So that node is called as a routing node. Network routing node is one possible functionality. Wallet is one functionality. Miner is another functionality. And the complete blockchain is another functionality. Full Bitcoin blockchain is another functionality, right? See, a typical Bitcoin core client, this is one user interface, right? So this interface has got all 4 components. That client can act as a wallet, it can act as a miner, it can act as a forwarding node, it can even store the full blockchain. Imagine the size of the blockchain, the whole of the blockchain can be stored as part of this client, right? So, but all nodes needn't have all 4 possibilities, okay? So what I'm telling you about the full node, full Bitcoin node will have all functionalities: routing, it will store the complete Bitcoin database, mining, and wallet service. See, some nodes are called as simplified payment verification node, SPV node, right? Will not have this much of capability, so can only maintain a subset of blockchain. So the whole of the database will not be stored in the SPV node, right? But instead, it will store a subset. We'll see what is the subset like. I mean, how much is actually stored in this SPV node. But there are 2 possibilities. One is a full Bitcoin node, another one is an SPV node. Right. So miner is, I've been telling you miner, right? So the miner actually, they all compete together. That is, they all compete in forming new blocks. Okay. They actually will have a dedicated hardware device. Those miners will have dedicated hardware, very high efficient, high-end system, right? Which would be able to do a mathematical calculation, which we call that as proof of work, right? So those items are called as, those entities are called as miners. So the miners can even be a full miner, or it can be an SPV node. It can be a full node maintaining the full blockchain, right? So the miner need to have the full blockchain, or sometimes it can be even a lightweight node, which will have a portion of this blockchain, right? So for the rest of the blockchain, right, it can actually be dependent on a pool server, right? So suppose if you are not able to get a high-end server which can carry out this mining, if you have efficient, I mean, a considerable amount of computing power in your machine, hope so, right? So in that case, you can become a part of a mining pool, right? It is not just one single miner, but instead you may have a mining pool where you can contribute your computing power and you will get the share of reward which is being paid. Okay, so either a full-fledged miner can be there as a part of a node, as part of a network, or there might be a pool, right, in which you are a member. Right, you can contribute some amount to that miner. Okay, so miner is nothing but like those equipment will compete for forming blocks. Okay, so why they actually go for competing in the sense you would be paid an amount for doing that. So to acquire that amount, you can become a miner. Okay. So then wallet you all know. So it can be a desktop machine or it can be a smartphone. Okay, which we usually call it as a simple payment verification node. Okay. Okay. So now a node is nothing but a miner himself is called as a node. A wallet himself can be called as a node, or a full-fledged node can be there in which all four functionalities may be there. Whichever it is, we call that to be a node, right? Suppose if it is going to be installed for the first time, right? So it won't know its neighbors, right? It's part of internet, right? That's it. You won't know who is the neighboring node, Bitcoin node. You may not know, right? How he actually finds his peers, right? So normally that miner software would have been installed hard-coded with a set of DNS server's address. So what the device can do is once booted up, he can call that DNS server to get hold of a Bitcoin node's address. Any Bitcoin node's address who is nearer to him, may not be nearer to him, whatever, wherever he is, you can get hold of an address. So it is hard-coded. The miner software would have been hard-coded with your DNS server's address. You all know what DNS server is, domain naming system, right? So you can contact this DNS server to get a hold of an IP address of a neighbor node. Okay, that is one way. Another way is, or sometimes when once installed, so as a part of installation, right, you could configure one of the Bitcoin node's address itself. Instead of coming through the DNS server, the system itself would have been installed with a Bitcoin node address, neighbor. Okay. So coming to know about a neighbor, right? So don't think neighbor means it's sitting next to him. He may be apart, distance apart. Okay. So we call him as to be a neighbor. Okay. So this newly installed node will open up a TCP connection with that node at port number 8333. After getting connected, some handshaking will happen, right? And then this newly installed node will get to know about some more addresses, some more nodes addresses, because the paths are not reliable in internet. So sometimes the path to your neighbor might be existing currently. After some time, it may not be there, right? So you won't depend on just one IP address. For the installation purpose, you would have installed with one address, right? But once having connected to that thing, you can get hold of some more addresses, maybe 10 or 20 addresses, maybe known to that newly installed node. Okay, this is the first part. Okay, so now after getting to know the address, the next step is, if the node which we are installing, right, if it happen to be a full node, right? So full node means you need to have the full blockchain stored in his machine. Okay, that full node, he will try to construct the complete blockchain. That's the first step, right? Once installed, he will get to know a neighbor. After getting know to the neighbor, he will somehow collect the blocks from him, right? So for that, he requires two parameters. One is the block height. Block height is from the Genesis node. So the block 0, it's called as Genesis block, which was created as a part of installation of the Bitcoin blockchain, right? So from where, now suppose if you are at level X, right? So the depth of this is X, right? Suppose if a newly installed node, I just have my depth as 0 because I just have only the Genesis block. I don't have any other blocks, right? So I will just find out what is your block height, right? If he says, for example, 6 lakhs, okay. All 6 lakhs blocks need to be transferred to my machine, right? You should not overwhelm him with continuous requests, right? So what you can do is, you could ask him to send a set of blocks hash values. Okay. So initially he will send me 500 hash values of blocks. right? Block 0, block 1, block 2, block 3, and so on till block 500, right? So I will just, the install node will just get hold of 500 hashes. After getting to know about the hash values, he will send the hash values to all his neighbors. So he may know about 10 or 20 neighbors, right? So he'll send hash value 1 to the first neighbor, hash value 2 to the second neighbor, and so on, right? So each one will get me back a block. Then I can form a blockchain based on the block number I'm receiving. So I should not overwhelm one receiver, right? So I just distribute all hash values to all my neighbors and get hold of the blocks, right? Likewise, I'll get hold of 500 hashes and I'll try to figure out my full blockchain. Okay. But if it is an SPV node, right? You just don't need to remember the full node, right? He will just store only the headers of the block alone. He won't get the complete block. I'll show you the block format later. But just time being, remember, I will just keep in mind that there are two parts. One is the block header, and another one is the block payload. Okay. So this SPV node will just store only the block headers. The payload will not be stored. Okay. I'll tell you what will be there in the payload. Anything? Anything? Shall I continue? Everyone can answer, no?
You can continue.
Oh. Okay. So the SPB node will just keep track of only the block headers. Okay. So now this is what I've told you. So assume that node A is a newly installed node. Node B happen to be his neighbor, right? He will send an inventory message which will have the block hashes of 500 blocks, right? Then he will send a get data signal carrying the block hash, which in turn he can get back the blocks. So this is in case of full node. In case of SPV node, he will just ask for the headers alone, not the full payload. Full block will not be retrieved, just the headers alone he'll store. Okay. Okay. Now what we have learned is, the third thing we have learned is how exactly a Bitcoin network appears to be. Bitcoin network has a lot of nodes. The node may be just a routing node, or it might be a miner, or it might be a wallet. Anything is possible, right? Whoever it is, once installed, you should somehow get to know about his neighbors, right? After getting know to the neighbors, he has to, if it is a full node, he has to synchronize a full blockchain with the neighbor. Okay. Now we'll see how many blocks are currently available in the Bitcoin blockchain. You should know the depth. See, the last block is inserted into the blockchain, Bitcoin blockchain is 660450, which was inserted 1 minute back. Whose size, see the size. A typical block size can be up to 1 MB. So in the example, I showed just a transaction of size 200 bytes, right? But actually, a set of transactions can be put into a block. Actually, the maximum size of the block is actually 1 MB. Okay. So this is a Bitcoin block number currently. Okay. So now we'll see when a transaction is raised, we'll see what happens, right? So after getting some material or whatever it is, I'm paying using my wallet. Okay. So that means I'm sending a transaction, right? So what the wallet software will do is, my transaction, right, will be signed with my private key. So wallet, you all know, it is going to maintain all my keys. There are 3 keys available. One is private, another one is public, another one is an address, Bitcoin address. Okay. So now first I raise a transaction. What my wallet will do is, he'll sign on my behalf. The transaction will be signed using my private key. The private key, of course, will not be known to anybody else other than my wallet. Okay. Now, once it is signed, the transaction is broadcasted to the Bitcoin network. So once a node installed, so I said he comes to know about his neighbors, right? So he will send a copy of the transaction to every neighbor. all neighbors. The transaction is broadcasted using a flooding algorithm. Flooding is nothing but whatever I'm receiving it, I'm sending it over to others. Okay, so I'll send it. It will be broadcasted. So every other node will have a copy of your transaction, right? So once the miner gets your transaction, right, what he does is he collects and he puts it into a pool. Okay, transaction pool. So the miner will choose the transactions from this pool and he will try to form a block. So the mining nodes include this transaction in the next block to be mined. Okay. So normally it is put in a pool from where he will choose and he will try to form a block. If he is successful with forming of that block, right? So he has to be successful. Not just mere putting all transactions into a block is not successful, right? He has to win the competition. We'll see the competition later. Once he wins the competition, right, he will actually again broadcast the newly mined block to the network, saying that and now I've done one mining. I've completed one mining. Okay. So then all the nodes, right, whoever gets a copy of the block will verify the valid, will check against certain issues, right? Is it okay? Is this condition okay? Is this condition okay? Is it been, every node would have been given a list, right? That list will be checklisted, right? And then if the checklist is okay, then again he will do the broadcasting again, right? Likewise, it reaches everybody. So whoever got the blockchain will add the newly added block to its chain. Everything is done in distribution, right? Nobody will try to have a conversation. So when I receive a block and if I found to be correct, then I will add the block to my chain. All chains will be synchronized. We'll see how it is synchronized later. Okay, right? Then after that, suppose if you are at height X, right? My block has been inserted at position number 8, right? So after X, few more blocks can be added up, no? So every new block added up after you, it's called as confirmation, right? So this confirmation will start to appear in the receiver wallets, right? So for as suppose if I'm paying a coffee shop, very meager amount, right? It is enough if the shopkeeper waits for one confirmation, right? So to make sure that this transaction is correct. So my transaction should have been included as a block, after which a new block, if it is inserted, that means that automatically proves it's correct, right? So the shopkeeper just need to wait one confirmation to make sure that your money is correct. But if it's going to be a huge amount, right? Sometimes you may need to wait for 3 confirmations, but whatever be the amount of money, it is enough if you have 6 confirmations after that. So what I want to say about confirmation is, if my block gets added up at the position X, right? After X, suppose if 6 more blocks are added up, that means 6 is my confirmation count. After me, 6 more blocks are added up. So that you have to wait for so many number of confirmation before making sure that the transaction is good. Okay. So now I told you about keys, right? So there are actually 3 identifiers in a Bitcoin technology. One is the private key, which is represented as small k, and you have a public key, capital, and your Bitcoin address, which is visible to everybody, it's A. Your identity will not be known outside. Your Bitcoin address will be alone available. So these are the 3 identifiers. We'll see how these identifiers are formed. Your wallet is responsible for forming it. We'll see how it is done. So private key is nothing but a 256-bit random number. Just a random number. That's a private key, which will not be shown out. You know what is asymmetric cryptography, right? So this private key is confidential. So you can form this 256-bit number like this. You toss a coin 256 times. Every time you get a head, you write a 1. Every time you get a tail, you write it a 0. So you do this 256 times, you get a 256-bit random number. That's your private key. Okay. So this, to convert it to a public key, right? So Bitcoin network has got a generator pointer on a curve. I'll show you now. There is a point. Point means you have X coordinate and Y coordinate. It's a point, right, on a curve. So the private key need to be multiplied with this generator point in order to get the public key. So this is what it's shown here. Capital K is equal to small k into G. G is the generator point on a polynomial. Okay. Same. How can we add, how can we multiply a number and a point? Right? So this is a point which is expressed as x and y, whereas this is just a number. And we need to multiply this, right? So to multiply this elliptic cryptography gives you a provision. So in this elliptic curve, if you want to add a point to itself, some xy, if you want to add that xy to xy, otherwise I can call it is to be multiplied by 2. Okay. So this, you draw a tangent at this G, that's generator point. You just draw tangent, which will intersect the curve at some other point, right? Whose mirror point along the x direction gives you 2G. So if this is my G, right? This is my 2G. That means I'm multiplying G with 2. To multiply with 2, right? I need to draw a tangent which will intersect the curve at some other point. You take the mirror image along the x direction. So this is minus 2G, this is 2G. Right? So this is for just for multiplying by 2. Suppose if I need to multiply by 4, right? If I need to multiply 4, then from this point I'll draw a tangent which will intersect the curve at point whose mirror image will get me 4G. Again draw a tangent, it will intercept here whose mirror image is 8G, then 16G, 32G, it goes on. So what actually we want? We just need to multiply K with the generator point. So this is how we draw. Right? So that's how we generate this public key using this algorithm. Okay. So now you know your private key and your public key, from which you can derive the Bitcoin address by applying a hashing algorithm. So hope you all know what hashing is. Hashing is nothing but it will map a arbitrary size of string to a fixed string size, right? So it is not like even a slight change, maybe a full stop or maybe a comma will drastically change the impact on the output. Okay, I wanted to say this. So because everything is based on hashing only here, right? So you have started with the private key and you apply the cryptography, elliptic key cryptography in order to find this public key, right? Now this public key K is used to compute secure hashing 256 hash value, and this RIPE MID, this is again a message digest to convert that into a Bitcoin address. This helps you much more. This is your public key, right? The first public key is given to this SHA-256 and then this to this message digest, which will get me the public key hash value. We have done only the hash, right, of size 20 bytes. Now this is applied to a base 56 encoder, which gets me a Bitcoin address. This is what visible to everybody, using which you could transfer amount to anybody. Okay, this is a Bitcoin address. So the relation is nothing but we use to sign our message with private key, right? And if somebody wants to validate is it has come from you, to check it out, they will use a public key. So the private key is used to generate the signatures on messages. Signature can be validated against a public key without revealing the private key. Okay. To spend an amount in Bitcoin, if I need to use an unspent output, I need to sign my transaction, right? So to use it, I'll have to send my public key as an argument to the script which I had explained you earlier. So the Bitcoin owner, he need to present his public key and the signature. The signature is nothing but the signing of the transaction, right? To spend those Bitcoin, I need to give my public key plus the signed transaction, both in order to make use of that amount, right? Anyone in the Bitcoin network, not just the sender and the recipient, can use your public key in order to check you are the one who has raised this request and you have the right to spend that money. Everything can be done, checked by anybody in the Bitcoin network. Okay. So what we have seen so far is, we started out with what a Bitcoin is, what a transaction is, and then we saw what how a Bitcoin network is there, right? So now we'll see what is a block in Bitcoin. So because it is a cryptocurrency which is going to use blockchain, right? So we need to see what is block here. So block is nothing but, you just imagine it to be an ordinary Word document which we type, right? So that document will contain a set of transactions. So what transactions have occurred and how these transactions impacted certain balances. So where I am transferring, from whom it has come from, right? So whole thing, if you're putting it into a Word document, that is nothing but the block. So this block and the blockchain, right? So that block in the blockchain is this, in case if you are using it for Bitcoin. So only this will be present as a part of your Word document. So this is how a block will appear to be. So I said there are two parts in it, right? One block header and your payload, right? So this is the payload part. So the payload part is nothing but, I will just have the list of transactions, right? How many such transactions are there is put in the transaction counter, right? And you have a block header. We'll see the fields later. And the total block size, right? And what is the block number? I said like it comes to some 6. I showed a number which starts with 6. So many blocks are there in the current Bitcoin blockchain. That's a block number. That's a block number. What is the block size? The maximum size is 1 MB, but no need to have always 1 MB. Maybe sometimes maybe lesser also. That's a block size. Okay, and you have a block header, right? And the transaction list. So the whole block is applied to this SHA-256, and you have a hash value. This is a link to the subsequent block. Okay, so here, if you notice in the block header, there is one field called as previous hash. You would have got a, suppose if this is block number X, you will have the X minus 1 block's hash value here. Here you have X minus 1, whose hash value will be here. Likewise, this is block X. In block X plus 1, they will put this hash value. So this is just an example. Okay, so this will link all the blocks. That's why it's blockchain. So version, hash, we'll see what Merkle hash is. Then your timestamp when this block is actually formulated. And there are two other fields, very important fields, the difficulty level and nonce. We have to see all these three. Merkle hash, difficulty, nonce. Okay. So if it is not very legible, I can show you. This is the blockchain. So this is what I told you. This is one block. This is one block. You have block size, block header, transaction counter, and list of transactions. Likewise, you have set of blocks. All blocks are interlinked with the help of this what? Block hash. I told you, no? So previous hash value. So this block header is in turn connected to the previous. Right. So this block header has got 5 fields. Right? So one is Merkle root. We'll see what Merkle root is, and then we'll see the other fields. So this is how a block appears to be. Okay. So now transactions will be flooded. Whoever, a lot of point of sales around the Bitcoin network, they'll all raise transactions. All transactions will be flooded across the network. Right? The important component is the miner. He'll capture every transaction and he puts it in a pool, transaction pool. When he has completed with the current iteration, he will pick up the transactions from the transaction pool and he will formulate a block and he will try to validate that format. So once he forms a block, it is called as a candidate block. It is not a confirmed block, right? He has to work on it to make it as a confirmed block. Once, if he completes a block, confirms a block, then he can actually flood it again to upload in the blockchain. The blockchain is distributed all over the blockchain node. So the mining is nothing but it's a process of hashing the block. It is just you have the block, so the block has to be hashed. Block header has to be hashed repetitively, right? Changing just one parameter. We have to change one parameter, right? Every time after changing the parameter value, take up the hash, right? So the reason is after taking up the hash, right? The resulting hash value should match a specific target. There are two indications here. One is one parameter need to be changed. Another one is you have to, the resulting hash value should match with the target. Right. So these are the two fields which I had shown you earlier. One is a nonce, Another one is the target. This is his nonce, this is his nonce, and this is here it is mentioned as difficulty, but actually it is target. We'll see how target and difficulty are related. Target. So now that is what mining is all about. So mining is a process of hashing the block header repetitively, changing one parameter until the resulting hash value matches a specific target. Okay. So this nonce is nothing but initialized to some random value. It is just a number. Okay. This has to be changed. Right. Every time I change and if I compute hash, you will get a different hash values, right? So that hash value should match this specific target. The target is expressed in terms of coefficient and exponent. I'll tell you what is coefficient and exponent now. Now, so the target is actually expressed as coefficient and exponent. Some number is there in the target. Okay. So like this. I have written in hexadecimal. Right? How many digits are this? See there 1, 2, 3, 4, 5, 6, 7, 8. So it is actually a 32-bit number. It was a 32. So of which the first two is the exponent and the rest is the magnitude. Right? So this is how we represent this target. Right? But actually this target need to be computed as this. Target is equal to the coefficient part into 2 raised to, okay, 8 into exponent minus 3. So here exponent is 19. 19 minus 3 you just compute. You just multiply it by 8. That 2 raised to that much amount into coefficient is actually the target. So for this example, the target like appears to be like this. This is the target value for this number. Okay, 19 is the exponent and this is the mantissa. Okay, coefficient. So what it means is, you change the nonce value of the header, you compute the hash, and the hash value must be lesser than this. Must be lesser than this number. So you have around 10 zeros here, I suppose. 10 into 4, 16 zeros. I'm not sure how many zeros are there. 1, 2, 3, 4, 5, 7, 8. 15 zeros are there. So 15 into 4 is how much? 80, right? So it should be whatever hash value I am getting at should be less than this. I should say otherwise all these zeros should be retained. Okay. Then you can have 3A 30 instead of C. It is B F. You can have your hash value from 0 to this number which I have told you now. Till this you retain as it is, no change to this. Okay. The C0, C all 0 should have to be replaced with B all F. Suppose if I say a number X for this target, my hash value must be less than X. That is what I want to say. So if it is less than X, I can have anything between 0 to X minus 1. Likewise, from 0 to this BFFFF, any number can be. That is how this is the basic of the mining process. This is the mathematical work to be done. This is called as the proof of work, or I should say this is the consensus algorithm. Everybody has to come to an agreement based on this. So this is how the target is represented. Right? What the procedure is for represents. I can't write every time this big number in my block header, right? So instead, if this is my actual target, I have to write this way. That is all. The representation goes like this. Is there any disturbance here from my side?
No, ma'am. No, ma'am. Continue, ma'am.
Thank you. Okay. Now, this is my target value. Now I'll tell you how to compute the difficulty. Only target will be given. Now you have to find the this is actually the target value. Okay. See, in case of Bitcoin network, they have configured this Bitcoin, right? So the interval between successive blocks is 10 minutes. Suppose if a block X is generated, the next block is to be generated only at X plus 10 minutes, not earlier than that, right? So how it is done is by adjusting the difficulty level. The rule goes like this. You have to generate a block every 10 minutes, not earlier than that. Okay. So what they do is all nodes present in the Bitcoin network, right? They will all do one thing every 14 days. Why 14 days is, we just compute 10 minutes. How many 10 minutes are there in a day, and how many such 10 minutes are there in 14 days, right? So that gives you approximately 2016, right? So within this 14 days, you should have generated 2016 blocks, right? Suppose if there are possibilities that you might have generated 3000 blocks within the stipulated time, or you might have generated 2500 blocks within that time. Whatever it is, you find the difference, right? How much time it has taken for the last 216 blocks. How much actually you have to generate 2016 in how much minutes? In 20,000 on 60 minutes, you should have generated only 2016, right? But actually, you might have generated more or you might have generated less, right? So based on the old target and the current actions which are going on, you manipulate and find the value of this new target. So when this is lesser number of blocks, you will have to increase your difficulty level. When you have more number of blocks being generated, it based on which you have to adjust the level of your difficulty. Okay. So now, for every block you mine, suppose if you have a miner installed, right? For every block you mine, right, you will be given 2 rewards. Now I should say the fee, total fee amount is comprised of 2 things. One is a reward, another one is a transaction fee. Reward is automatically generated. Initially in 2009, when the Bitcoin network is installed, right? Once, suppose if you mine a block, you would be given 50 BTC. Would be given 50 Bitcoins. After 4 years, it is halved. It has been programmed that way. The Bitcoin network is being programmed that way. Every 4 years, it has to be offed. Now, actually, the current value is 6.25 BTC. After 2140, there won't be any new Bitcoin issue, right? Only based on the transaction fee, the miner has to manage. That is why the name is mine. When you mine for metals, right? So the reduction, the reward will goes on decreasing, right? So likewise, initially they started up with 50 and now we are at 6.25. Every 4 years it gets halved, and after 2140, there would be no more Bitcoin generated. The miner has to depend only on the transaction fee. So as I told you earlier, along with this reward, you have a transaction fee. Suppose in a block, if there are 100 transactions and all 100 transactions are ready to pay, for example, 0.1 BTC, for example, I'm telling you. So all these amount comes to the miner. Right? Any guess how much Bitcoin value is? You can check. You just find out how many lakhs of Bitcoin correspond to. So just think about a miner, because you need to spend a lot on installing a miner. You should have a very high-end CPU, right? Or maybe a mainframe system with large fans, and you need to have a space to store all computing resources, right? So he has to be paid based on this reward. Okay. So now we'll focus on the consensus method. So the consensus is the agreement, right? So a block is to be added onto the blockchain. Everybody should give the concurrence. Okay, this is correct. You can add up, right? Everybody will add their add the block to their list. That's actually called as the consensus. Okay. So now, how Bitcoin network achieves global consensus without any central authority. So you don't have a central authority. Okay, you accept. To say that there is no one. Everybody, they themselves will have to figure out whether it's correct, whether can we add it to our blockchain. But all the blockchain entities, wherever the copy is, will be synchronized. Has to be in synchronized state. Okay. So these are the 4 steps. We'll just explain these 4 steps and we'll finish it up. So the independent verification of transaction. Everybody, whoever is there on the network, will validate your transaction. Validating a transaction is nothing but, verification is nothing but, they will check, are you the one who has raised the query, or are you the one who have raised the transaction, and do you have that much amount of money to spend? Right. So these are the 2 things which will be checked by every node. Whenever a transaction is raised, everybody will do that. So that makes sure that you're not wrong. Okay, that's the first step. Second step is, once a transaction is verified, right, the transactions all need to be aggregated and put into a block, right, and then they will use the proof of work. This consensus algorithm of Bitcoin network is proof of work. Okay, so its proof of work will be used, right, in order to form a block. Everybody in the sense, all miners of the network. Every miner present in the network will have to do this independent aggregation, right? And once they're sure they formed a block, valid block, then they will again broadcast. Everybody present on the network need to verify the block whether it's correct. All transactions are correct, everything is correct as per standard. It's there. Everyone will check on their own, right? And then it is to be added on to a chain. So there are possibilities that there are slightly some two chains are there. We'll see how a chain, double chain is formed, right? So you have to choose a correct chain to add it to that network. These are the four. So first is, I'll just explain the first one, independent verification of each transaction. So the wallet creates a transaction. The transaction is sent to all neighbors. Every node will check whether the referenced output must exist and cannot already be sent. Referenced output means when you spend some amount, you have to refer your previous transaction which has given you this amount, right? That is reference to the output of some other transaction. So everybody will check for each input, the reference output must exist. Otherwise, you are not eligible to spend that money. That will be checked by everybody. And for each input, there should be an output exists. That output addresses are correct, right? And then otherwise, if there is no such receiver or something, that transaction is rejected, right? And suppose if you want to open up a transaction, you're going to spend your money, somebody has sent you, okay? So you have to give the correct unlocking script. Only then it will make sure that you are the one who has raised the request. So all these things will be checked by every transaction. So and nobody can actually induce any blocks intentionally, unwanted blocks intentionally. This is second. Aggregating the transaction. You collect all transactions from the pool, aggregate that into a candidate block. It is not the final one. You have the candidate block. In the candidate block, you change the you change the nonce value, compute the hash value, check whether the computed hash value is within the target. Then it becomes your valid. Everybody in parallel, they would be doing their own calculations, right? Somebody winning first, right, will send the block to every other node, right? So every other node will check out whether he has really done the proof of work, and if he so, then he adds it to the blockchain. Okay. So actually the construction is this, no? You have to collect all transactions to form a block. So these are the fields present in the header. We had seen this version. Version is the version of the Bitcoin blockchain software. And this previous hash value is the hash value of the previous node. This is Merkle tree module we haven't seen. Timestamp, the time at which this block was ready. Target and nonce, what target I've used and what is the nonce value after computing the POW. Right, all these are added up and you have to form a block. So now one thing is left out is this Merkle root. I'll just give a slight introduction. There's a huge thing to say actually, but I'll try to give a introduction. So suppose if a block has got 16 transactions like this. This is transaction A. This is not transaction actually. You have transaction underneath. You have transaction A, B, C, D, E, F, and so on up to P. Right? You just find the hash value of this your transaction, then becomes HA. Right? Then you just combine the two neighboring transactions, you form a hash. Then you just combine these two, form a hash, and you form a root likewise. So this is actually the Merkle tree. Merkle tree would leave it's nothing but all the transactions of your block. A block may have hundreds of transactions, right? So because size is of 1 MB, just one block, one transaction size is around only 300 bytes. So just think about how many transactions will be there in a block. All blocks, all transactions are listed out here, whose values, hash values are computed, and then finally you have a root. Okay? So this is used by the SPV node I've told you, simplified payment verification node, which will use this tree, right, to find out whether such a transaction, you might say, this is where my amount comes from. I would say a transaction ID, right? So this is where I've got money, right? That transaction need to be checked if it is present in the tree, right? For that, they use this Merkle tree because the SPV node will not store the full blockchain. Instead, they will just only store the block headers alone, right? So based on the hash value, with minimal number of, suppose if I want to check whether HK is present in this block, right? Somebody is giving me HK. right? I want to check out whether HK is present. In order to verify whether HK is present in this block list, I need to just give only 4 other parameters. I don't need to give the whole lot. Just which have been marked in blue alone need to be given, right? So only these 4 need to be given. I know this. This is what I want to check for. When my neighbor is given, I will find this. When this is given, I will combine this and I'll form this. Which are marked in dotted is being calculated. Okay. So once this is ready, if I had known this, then I would be able to compute this. Then if I had known this, I would be able to compute this. If this hash value matches, then I can be sure that HK is present here. So why I want to check whether such a transaction is present? Because I'm spending some amount of Bitcoin. That Bitcoin has come to me via some other transaction. I should check whether such a transaction is existing in the block. Right? If the whole block is present within the node, he can easily check out whether such a transaction is present. Otherwise, he has to find, because he has only the headers present. Only by making use of this Merkle tree, he can figure out whether such a transaction is existing in the block. So that is this header. That's a Merkle root means actually. Okay. So now, after successfully mining a block, that means you have adjusted the nonce value, you have computed the hash value and check whether it is lesser than target. Then you will start flooding the block. Okay. So this hash algorithm, what I just wanted to say what a hashing is an arbitrary length of data input and produces a fixed length deterministic result. It's just a printed of the input, it can't be retraced back. So once a block is ready, now it's time to validate. Validate is, you have to check whether all transactions are correct within the block, all the fields are correctly installed, right? The size is very much limited, right? So all these things have to be checked out and then again flooded. Okay, after flooding, now check out. So actually validating needs this checklist to be verified. Block data structure syntactically valid. Block header hash is less than the target. Is a proof of work done and is it less than the target? What is the timestamp at which it is being fixed up? What is it within 1 MB size? Is the first transaction is coin-based transaction. This coin-based transaction is nothing but the reward. When I form a block, I said I would be given a reward of 6.25 BTC. No, that is to be represented as a transaction because there is no physical Bitcoin. All Bitcoins need to be represented as a transaction. So that transaction is this coin-based transaction. And then all transactions within the block are valid. This is how we validate a new block. Every other node, right, will check out all this before adding up to the blockchain. And the final step is you need to add up to the blockchain. The thing is, while you're adding up to the blockchain, at some time, there would be 3 chains possible. One is primary chain, then you have a secondary chain, and you have an orphan chain. Okay, I'll just tell you the difference. It's easy. So now assume that this is just a peer-to-peer network, initial setup, right? So this is the figure doesn't show all the blocks. The last entry of the blockchain is this star. So all are synchronized. Each one is maintaining a blockchain. The edge of the block is nothing but the star. Sorry, it's star. Okay. Assume at a given point of time, there are 2 miners. Here, we call them as to be X and we call them to be Y. They actually form blocks, right? He has formed a valid block, not a candidate block. He has worked and he has won. Okay. His block ends up with this triangle. Okay, just to identify. Okay, he has ended up with a different block which is ending up with this triangle. Right. Once a block is valid, they need to flood up. Flooding is this node will generate it to its neighbors. He in turn will generate it to neighbors. Likewise, he would have generated to the neighbors. He would have generated to the neighbors. Right. It will take some time to propagate. Right. So before the propagation is over, right, they have formed the network. They form a blockchain like this. This is my blockchain. These nodes who has got this upper triangle will have this as the blockchain. So he will have this as the blockchain. He will have this as the blockchain in yellow. Whereas all these which are marked in yellow will have their blockchain as this because it is ending up with this inverted triangle. Okay, so this is the scenario. Okay, at a given time, there are 2 nodes have come up with a block, 2 different blocks. They're not one and the same. They need not to be one and the same because he might have chosen a different set of transactions. He might have generated a different set of transactions, right? And they have worked on it. They have won. They've got a target. They have got a nonce value, which they've got a hash value which is lesser than the target. So they have correctly ended up with a block. So now the next job is to flood the block actually. So these have upgraded to this triangle and these have upgraded to this triangle. Okay, now what happens? After some time, this triangle, this block will reach this extreme. Likewise, this upper triangle will reach this Y after some time. What they will do is, already they have a blockchain here, right? Now there is a new block whose predecessor is the same because he is pointing to the previous block hash. Both of them are pointing to the same predecessor, parent. So you can't add this block after this because he is not the parent of this. He is the parent. Parent means the hash value. So he will connect two chains. Now there is a possibility of two chains here, right? But this will be resolved in the next flow. See here, after some time, there is a node who has come up with a new block which is marked in a diamond. Okay, now this diamond is flooded. So when this diamond is, see actually you see this node has got upper triangle as the last node. So the who is winning for the next time, right? The one who is going to win for the next time has got its status as upper triangle. So he would be the predecessor of this block he is generating. So what he will do is he can directly add up with this upper triangle. Now this is left as an orphan. This is called as orphan. Only for a particular instant there are two chains available, but now it will be converging because he is a parent of him. Okay. Now the length of this is more, so he becomes the main chain. Okay. So this becomes orphan. So whatever blocks present in this orphan block will be removed and will be put in the transaction pool if it is not already included elsewhere. Right. So now after a while the blockchain, likewise here he would have got this. He also has got two things, but when this is flooded, he can't put this diamond after this because for this diamond node, he is a predecessor. So he can put it only here. Right? So he grows. So the chain which has got the most POW will be chosen as the main chain. The other one will be considered as the, what should I say, secondary chain. Okay. So hope I've given a brief introduction. I can't cover everything, such a lot of information are there actually. So if you're going to work on this Bitcoin, actually you might write some consensus algorithm. You can identify some issues with the existing consensus algorithm. You can develop, that is one, but I won't say it is on Bitcoin, but it can be on a generalized distributed system. You can write new consensus algorithm. That's one thing. But if it is going to be for Bitcoin, right? You can study the impact of Bitcoin, quantum computing on Bitcoin mining. So for mining, you are given 10 minutes of time. Okay, so the block can be mined, right? Suppose if I bring a quantum computer and if we can do at a very faster rate, right? So there are chances for hacking as possible. This chain can be breaked at any point of time. Okay, so you can study that impact of, there are a lot of quantum simulators are there. You can write quantum algorithms for mining the Bitcoin and then you can test it. This could be one challenge. Another one is you can integrate the IoT technology and the cryptocurrency. So why I say this is, see, suppose the typical example we used to hear on IoT is this. Suppose if milk is going to be below a threshold, your fridge can order directly for milk. Right? So that is where the IoT comes into play, right? So naturally the fridge can't open up a ATM card or something and pay for it. Naturally it will lead to Bitcoin. It is too early to design now actually, but you can see the methods for integrating such IoT technologies and the cryptocurrency. For payment, if devices are going to be initiating the transfer of money, then obviously cryptocurrency comes into play. So we can actually think of integrating the IoT and cryptography. Okay, with that I'll close. If you have any doubts, you can ask me.
Participants, if you have any doubts, you can ask.
Ma'am, Sakthi
Yes.
ma'am.
Yes.
Ma'am, I have one doubt, ma'am, regarding why we can use it Merkle tree, ma'am. Hello?
Yeah, I can answer. The Merkle tree is used by, I told you, SPV node.
Yeah.
The SPV
Okay.
node will not have the complete blockchain stored within itself, right? He'll have only the block
Okay.
headers alone. Okay.
Okay.
Suppose if a
Mm-hmm.
transaction is raised and if we need to verify whether the transaction is valid, right? So first thing is see whether the input for the transaction it's correctly originating. Do that person have that block cryptocurrency amount for spending? He has to check it out, right? For that,
Yeah.
he has to check out the parent transaction, whether he has got that much amount of money for spending. The transaction is
Yeah.
not independent, right? So he has to check out whether he has got enough money for spending, from whom it has come from, whether it's such a valid transaction is already present in the blockchain. He has to check it out, right? So to
Yeah.
check out whether such a transaction is present in the block, you don't have the complete information. If he has got the whole blockchain, he can go through the blocks one after the other. Okay, right? So for that he need to every block will have a Merkle root actually, right? Merkle tree hash root will be there. So he has to just give the transaction ID, right? So he has to verify. He can ask up the block where that transaction is present. The block can give back the shadowed blocks which I had shown you earlier, right? 4 blocks, right? If you can give
Yes,
me
ma'am.
back
Yes, ma'am.
those 4 blocks, I can easily find out whether the expected transaction is present in the block.
I thought this one is very, ma'am, very efficient. No, ma'am. Merclity for both blockchain. I mean, Bitcoin and Ethereum and others.
Yes, yes. Actually,
Oh.
it uses a filter. Actually, now, I didn't tell you about the filter. Actually, you can actually
Okay.
express the transaction ID in the form of filter. Is the first bit, third bit, and fifth bit are equal to 1? Likewise, I can set
Oh.
filter based on the
Okay.
filter output. You can check out the transaction and you can get me back. That is the reason.
Ma'am, one more doubt regarding in our RBI actually not permitted. No, ma'am, in this
Yes,
Bitcoin
yes,
regarding why,
yes.
ma'am? It's very, it's any security less and what are the other things?
No,
Anything, ma'am?
actually in India they don't.
Yeah.
Legally, Bitcoin is not supported. It will take some
Mm.
time to settle
Yeah.
down.
Yeah. Okay. Okay. That's a thing. Thank you.
ரஃபா படிச்சிருக்கேன் சார்.
And any persons have any queries? Okay, right. Okay, on behalf of CEC department, I would like to thank Sakthi Mala madam to have the presentation, and the complete session was quite good and interesting. And thank you, Sakthi Mala madam.
Okay,
And,
thank you.
madam, please share your PPT so that at the end of the day we will share to the participants.
Okay, okay, I can send you that.
Okay, right. Thank you, madam.
you.
And the participants will come back by 11:45. So after a break, you can come by 11:45 in the same day. Thank you.
Oh, thank you, sir.
It is important. ஐயோ நான் இவ்வளோ நேரம் அதுக்கு சார் வெயிட்